We're going to take a look at the structure of atoms. And to do that, we're going to look at a classic way to model the structure called a Bohr model of an atom. That's Bohr like Danish scientist Niels Bohr, not like you're bored. So every atom is composed of subatomic particles, protons, neutrons, and electrons. Electrons are negatively charged, and, as you might have guessed from the name, these are the things responsible for electricity. Neutrons have no charge, which is why they're called neutrons, like neutral. And protons have a positive charge, because people who are positive about something are very pro-it. Protons and neutrons live inside the nucleus, the center of the atom. And protons and neutrons are really what gives the atom its mass. Electrons, on the other hand, while they do have some mass, it's such a small amount that it really doesn't contribute much at all. Okay, so let's take a look at these parts in action. So first of all, let's just take a neutron. A neutron just by itself is not an atom. It's just a subatomic particle. In order for this to become an atom, we need a proton. When I add one proton, I get hydrogen. This plus sign up here means that this atom is positively charged. That's because it has one neutral and one positively charged subatomic particle and nothing to balance out that positive proton. But if we add an electron to the shells around outside, watch what happens. Now the whole atom becomes neutral because the positively charged proton and the negatively charged electron cancel each other out. And the neutron doesn't contribute anything to charge. So now we've just made hydrogen the first element of the periodic table. How do we get the other elements? Well, let's try adding some things. Let's add an electron. Still hydrogen, but now with two negative charges and only one positive, we now have a negatively charged atom. Okay, so adding an electron doesn't change the type of atom. Let's try adding a neutron. Oh dear. Not only have we not changed the element, but we've also made an unstable nucleus. That basically just means that the forces holding this nucleus together aren't strong enough. And we've just turned this into something radioactive. Okay, let's take that neutron away before someone gets hurt. Well, only one last thing to try. Let's add a proton. And now we've got helium, the second element on the periodic table. Every time you add or remove a proton, you change the type of atom. You change the element that you're looking at. Every single element on the periodic table has a different number of protons, and that corresponds with the atomic number. It doesn't matter how many neutrons you have or don't have. This is never going to change the type of atom that you have. It's also not going to change the charge of the atom that you have. But having the right balance of protons and neutrons will determine if your atom is stable, not radioactive, or unstable, radioactive. Adding electrons doesn't change the type of atom you have. It doesn't affect the stability of your nucleus, so whether or not it's radioactive, but it does affect the charge of your atom. When the number of electrons balances the number of protons, you have a neutral atom. When you have an extra electron compared to the number of protons, you get a negatively charged atom. And when you have an extra proton compared to the number of electrons, you get a positively charged atom. So let's review subatomic particles. Protons are in the nucleus. They add mass and positive charge to an atom. The number of protons determines what type of element you're looking at. Neutrons are also found in the nucleus, and they add mass to the atom, but no charge. They also have no effect on what type of element it is. And electrons add negative charge to the atom, but don't affect what type of element it is.